that that befall ICT projects, because our course is ICT project management. So these are risks that are a bit more specific to software projects. But of course, we have projects in construction. We have civil construction. We have projects in architectural construction. We have projects in electrical engineering and so on. So the risks that are covered there are a bit different from the risks that you'll find in in software projects. So today, my emphasis will be more on ICT projects, and in particular software projects, because most of the time you people will be working on software projects. Okay, a few people maybe will venture into network implementation projects, but majority of you will deal with software projects. But a lot of the things that I'm covering here are generic. So you can take what you'll have learned here and apply them into other projects, and especially for those of you who will go under network implementation projects. So at the end of this lecture, what I'll explain found in a project, categorize project risks, and then explain the various models for managing risks, or rather project risks. So as an introduction, we look at risk management. So risk management looks at the management of risk during the project. Now, risks vary in importance. In fact, throughout the lifetime of a project, you will encounter risks. Now, what risk management involves? It involves you identifying the risks and you categorizing the risks and prioritizing the risks, so that you know what to ignore and what not to ignore. Now, the importance of a particular risks depends on the project. Now, like I've said, we have various types of projects. So you may find that in one project, a risk is minimal, and yet in another project, the risk becomes very important. So what risk management does is that it reduces the danger of risk for that particular project of interest. Now, risks is one of the, and it's because sometimes it's very difficult to know beforehand what is going to happen. Now, you've seen what has happened from last week, 2 weeks ago, that a place like Garissa would be cut off from most of the rest of Kenya. You wouldn't have thought about that 2 weeks ago. Now, imagine a situation, the road between Nairobi and Garissa, some risk has been swept away. Now, that bridge was already existed. Now, imagine a situation, you are a civil engineer, a month project. Where would you have known that? You would not have known. So this is why sometimes why a lot of projects fail. Because during the planning process, there are unforeseen things, and especially natural things which occur, and you cannot put them in the plan. So that's why there is the process of, first of all, risk identification, trying to think of anything possible that can occur and trying to see how to deal with it. And then there's what is called risk management, where you are into the project and something that is unforeseen occurs. So that's why we have to do risk management. So we need to categorize risks, and we can categorize risks into three types. So the risks found, types to be found in projects, are those caused by inherent difficulties of estimation. Now, before you start a project, you have to plan for the project. Now, when you're planning for the project, remember what we were doing. We did Gantt chart, we did scheduling, and we did critical. The good thing is that you sit down and you try to think ahead of time. But some you cannot think of every possible thing that is going. It is one type of risk that is found in projects because of its to come with ways of estimating the cost of a project. Very few times will you estimate a project. Then with risks that come due to assumption made during. Now, most times you will assume that things will work perfectly. So as you are planning, you assume things, but in reality, something unforeseen will always occur. Then those of unknown, then we have risks, unforeseen, or at least unplanned events occurring. So we categorize in that. So some tasks are easier to estimate than others. Manual you make to test and debug. But if somebody told you to go and do a feasibility study, a lot of times it's going to be a straightforward task, and especially if you are if it involves you meeting people and you plan and schedule, it's fairly straightforward. And debugging, which most of you will be doing, you shall find that it's not. I mean, in 6 months. The customer, where you have to talk about the program specification. So analyzing historic can deciding the level of accuracy to be assigned to a particular estimation. Now, remember, just of the course, I talked about you keeping records. And if you remember when we were talking about Gantt charts and and it's important in a schedule to talk about the scheduled time and the actual time. Schedule start time and actual complete time, and to keep records of this. Now, this is why you have to have a project file. Future, like right now, if I tell you to do, but exercise. So you are doing it because we have told you to do it. But in future, when you venture into projects of your own, you must keep a schedule and you must say the actual start date and the actual you make the planned start date and the actual start date, planned finish date and actual finish date, and then in the remarks section you must say why. Now, that is part of what is called historic data, and that's why we have to keep a project file. So that if you're in a project and you have all the documentation, in future, if you meet somebody who asks you to do a project and you think it's similar to the previous one, you will go to your project office and pull out that and look at it, so that when you're talking to the customer, instead of telling him it will take 6 months, you'll tell him this project will take 8 months. Instead of telling him that this project will cost you 6 million shillings, you'll tell him that this project is going to cost you 8 million shillings. So, and this is where we are talking about analyzing historic data. You have kept your information. Analyzing means why did they meet this target? Now, once you answer that, then when you are talking to your customer or client, you are giving him accurate information. And this reduces the estimation errors. Then we have what are called planning errors. Assumptions are used when planning. So if the assumptions are wrong, then the plan is at risk. For example, the need for rework may not be planned. He'll start doubting you if you start using words like, if I fail this task. He'll wonder at your level of competency. So sometimes you will not even bring up the concept of rework, because if you start using those terms that in case this happens, then so you'll find that some of these things are not planned, and yet it's inevitable that you'll have to go back and do some rework. And this is very notorious for software projects, because between gathering requirements and designing the system and actually implementing the system, a lot of things happen in you are moving back and forth. So when the plan is prepared, assumptions that have been made should be listed. So you should say assumptions. Now you are planning to the client. So you'll tell yourself, I'm assuming that the supplier is going to supply on a time. So that is an assumption that is going to supply it on time. So you list these assumptions, make all of them and list them, so that they are on the back of your mind in case they should occur. Details should be given of the effect of the plan if the assumptions are incorrect. So you don't just list the assumptions. You say what would happen if this thing happened, what you should do if that thing should happen. That is what we mean. Check if somebody wants to join. And then it is. Some eventualities may never be foreseen. That it is expected that such eventualities do happen even if they are rare. Most eventualities identified and predicted. For example, the required hardware not arriving on time. Plans should be in place to minimize the damage caused by an unforeseen event. So here, what we have done is we've covered the risk categories. So inherent difficulties in estimations, risk brought about by assumptions, and the risks brought about by unforeseen or unplanned events occurring. So, having seen that it's inevitable that we'll have risks and having categorized them, then we need to look at how do you manage risk, because we've seen risk will occur whether you like it or not. So there are generally in all projects we have two main elements in managing risks. We have what is called risk identification and now we have many more models, but identify the risk and you must manage the risk. Now we have many models. For software projects model, this was proposed by Bohm in 1989. So he came up with this model in a paper was published in the IEEE Computer Society. So this model is specific to software projects. So he calls it risk engineering, and he says is divided into two parts. We have risk analysis and risk management. Now, risk analysis is before you start the project. Risk management may in part apply to before you start the project and after the project has started or when the so risk analysis is divided into risk identification, risk estimation, and risk evaluation. Are lumped together. Risk estimation and risk evaluation are treated together, and that's what we are going to do today. Now, risk management can be divided into risk planning, risk monitoring, risk where risk directing and staffing sometimes are also lumped together. So let us look at each in turn. We start with risk identification. So risk identification is the identification of tasks the identification of hazards that may affect a project, that may affect a project risk assessment. So you must identify hazards. But what is a hazard? A hazard may adversely affect the project. Now, I've given you an example in civil engineering where I said, supposing you're a civil engineer, you planned a bridge, and the more you start constructing the, what has happened in the last 10 days or so, now in software projects, it may be the supplier tells you that the ship that was bringing this product has the past 4 or 5 months, the value of the shilling against the dollar rose sharply. Then it suddenly dips. So, so that becomes what is called a hazard, things which are going to affect your project. Now, some hazards are generic, others are project specific. Something like inflation is generic, it affects all projects. Something like El Nino is project specific. It's most likely to affect civil engineering projects. So the risk a hazard presents to a particular project must be decided. So what is going to happen if this hazard occurs? So you need to think about that. So you'll say, oh, okay, because of El Nino, there's going to be delay. So delay becomes a risk. So checklists are often used to help in identifying hazards, and the knowledge-based system software is also available to help with the task of hazard identification. Now, why knowledge-based software? Knowledge-based software, I'm sure by now you know it. Knowledge-based software or knowledge-based systems evolved after expert systems. In other words, expert systems came before knowledge-based systems. Now, why were they called expert systems? They were called expert systems because it takes long for someone to become an expert. It takes many years. So those systems were developed to preserve the knowledge of an expert. Now, like in medicine, we have surgeons. Then even surgeons, we have neurosurgeons, or we have orthopedic surgeons. Now, those are called experts. Why? Because one, they first of all became doctors. They went through the 7-year course, they became doctors. Then once they become doctors, not all doctors are called experts. So they went out there in the field, they practiced as general doctors. They realized that with the time, they were interested in something. They went and studied further. After studying further, they now do not practice those general things. They are now doing specific things. And those things are very specific. And that's why it's called an expert. And by the time someone is being called an expert, it has taken many, many years. And one thing that characterizes an expert is what I call heuristics. Heuristics means rules of the thumb, things that you'll never be taught in class, but things that you learn from experience. Now, that knowledge takes long and it could be expensive. So expert systems came about to capture that knowledge. So why did the expert systems become knowledge-based systems? Why did they evolve into knowledge-based systems? They evolved because it was realized that not all knowledge is got from human beings. Knowledge can be got from many other sources other than from an expert. Like right now, the internet is a great source of knowledge. So the term expert systems was evolved from expert systems to knowledge-based systems. Now, why do we talk about knowledge-based software is available to help with the task of hazard identification? We need knowledge-based systems because identifying hazards is a difficult thing, because here you haven't started a project, but you're trying to identify what can go wrong. Now, how will you know that if you have not been in that field, if you have not done that? But you see, if you have done it, it becomes much easier for you to identify. It becomes much easier for you to sit down and try to conceptualize what will happen. So if you bring together many experts, they can come up with possible hazards that can occur to particular projects. And that's why here we are talking about knowledge-based software. So before a project begins, it is good to do what is called risk identification, and risk identification becomes easier if we have expert knowledge. So we have various categories of factors which need to be considered, and in this case, we are focusing on software projects. So in software projects, what could bring about hazards? Now, hazards could be brought about by application factors. So the nature of an application, for example, a simple data processing system versus a safety critical system. Now, if you are trying to identify the hazards and hence the risks of a simple data processing system, that is going to be an easy task. But for a safety critical system, like you want this system that is going to control an aircraft, then identifying the hazards becomes very hard. Now, if you remember, there's this new plane that came recently. I mean, that has been having a lot of problems recently. It was even withdrawn from the market. I think it was by Boeing. Before it was launched, there was a lot of hype and a lot of praise about it. But then you realize that, in fact, it said that it's removing a lot of tasks from human beings. But once the plane was in operation, things started happening, things that were unforeseen. Planes started doing things that were not expected to be done. So that's an example of a safety critical system. So the designers of that system could not see those things that particular plane was going to do. So the application factors, what are you going to use this product for, is a determinant of the level so that is you can categorize hazards in terms of the application factors. You can categorize risks, identifying risks in terms of the staff factors. For example, the experience and the appropriateness of the experience, the skills and the turnover rate, the level of absenteeism. Those are things that are going to influence the success of your project. And those are things that are going to introduce hazards to your project. So you need to know, because projects are done by teams of people. You need to know their level of experience, and it doesn't mean that if somebody has done 10 years, somebody tells you it's 10 years of experience. Supposing those 10 years he was simply dealing with simple data processing system, is he now experienced? Are you going to count those 10 years and say he can do a safety critical system? He will have zero knowledge in safety critical systems, despite the fact that he has 10 years of experience in simple data processing systems. Then project factors, where, like I said before, projects are unique. So you define the project, list the project objectives, the team members understanding of the definition of the project and the project objectives, and the project quality plan. Now, project factors have to deal with project management. So are people who are in this project, are they aware of project management procedures and techniques? Then project methods. Is this project, that is this method that we are using a structured project method like Prince2 and so on? Now, later on, like I said, I've given you the fundamentals. Later on, we'll be talking about things like this, the Prince2 and so on. Because in project management, we sometimes use structured methods, and Prince2 is one of those structured methods. Now, like now, you are doing very generic project management techniques. You go out there and people tell you, you join a company and they tell you, we use a structured method like Prince2. This means projects in controlled environments. This is a structured method. So just like the other time we were talking about the agile method and so on. So you'll find that we have very many different project methodologies. So you will say, yeah, I have skills in project management, but you have skills in project management, but those skills are generic. You didn't do a structured methodology. Then hardware and software factors, where the use of new and tried hardware carries a higher risk than using existing hardware. Where a system is developed from one type of hardware and software platform for use on another, then will carry higher risks. For example, if we think of operating systems, we have Linux, we have Unix, we have Macintosh, we have Microsoft. All those are operating systems. If you develop an application for one operating system, is it going to work the same way as it works in another operating system? So that introduces a risk factor. Then changeover factor, where an instant changeover carries greater risk than an incremental changeover. You are changing over from a manual system to an automating system. How are you doing it? Do you say from 1st of June, we are leaving our manual system and we are going to our electronic system? Or do you say we are going to run them in parallel? Now, of course, if you do it instantly, the risk factor is going to be quite high. But if you are doing it in parallel, you reduce that risk, but the cost is going to be higher. Then supplier factors, they introduce risk. It can be difficult to control suppliers. For example, installation of phone lines, delivery of equipment, and so on. Why it's difficult to deal with suppliers is that suppliers are in the business of making money. So he'll promise you something today. Someone comes and tells him, mine is urgent, and I'm going to offer you 1.5 times what you've advertised. He's going to disappoint you. He wants to make money, so he'll supply the other person before he supplies you. Then and suppliers are difficult because you can see sometimes even in simple things like petrol, somebody anticipates that the price of petrol will go up, so he just decides he's not going to release petrol because he's waiting for that day and the time when the price will go up. So we will get what is called an artificial shortage. I'm sure you've been hearing of that. Now, that is how suppliers behave. So those introduce risk to projects. Then environmental and social factors, generally outside the control of the project. For example, changes in legislation, the law is going to change. For example, public opinion, a group just comes and says, no, this is degrading our environment. And remember, you have planned for the project. The project is starting, and somebody comes and says, no, environmental factors were not taken into consideration. What do you do? Then health and safety factors. Not generally a major issue for software projects when compared to other engineering projects, but still, if you're dealing with the software projects, you still need to take them into consideration. So you need to do that to ensure compliance with statutory obligation, because you may ignore something, but the law changes, or somebody says there's an aspect of law that you have ignored. So these are many things. So we have just categorized into those few. So when you are doing this risk identification, you could identify risks under the things that I've been talking about: application, staff, project methods, software, hardware, changeover, supplier factors, and so on. I've ignored things like ethical factors. In fact, ethical factors should be under software. Just today, I was reading. I'm sure you know about this. The SHIF. Now, it has been pushed. It's being pushed. We are moving away from national health insuring factor to the SHIF. Now, it's almost gone through. Now, what is happening? MPs, the same people who passed this, are saying, no, I think we should remain with the NHIF because ethical issues were not being considered. Data protection. You've already passed the law, but we're talking about data protection. Now, this applies to us because in software projects, we are dealing with the data. So when you're dealing with data, then you are dealing with ethical issues. So these are just a few of the things, but they give you a guidance in identifying risks. What are the hazards? And these hazards, what risks will they bring to the project? Now, I've told you a hazard is something that is likely to occur. Now, supposing it occurs, where does risk come in? Risk comes in because it's going to affect your project. Where's the risk? The risk is my project will delay by 6 months. My project will overshoot the budget by 2 million shillings and so on. So according to BOM, you should start with risk identification. Then you go to risk estimation and evaluation. So once identified, risks should be assessed for their possible effect on the project. The level of the risk the level of importance of the risk must also be established. You have identified the risk based on the risk, what I've been talking about. You identified them. Now, the next thing is to look at the importance. Now, what should I look at first? What should I look at last? What can be ignored and what should not be ignored? So you need to put a value. You see, for you to say something is important, there must be a measure. There must be a metric of that. So this is why the level of importance is also known as the risk value or the risk exposure, where the risk exposure is the risk likelihood times the risk impact, where the risk likelihood is the probability of a hazard occurring, the risk impact is the effect the resulting problem will have on the project. Now, easier said than done. You need to put quantitative values to these two, the risk likelihood and the risk impact. Now, just a bit more. Risk likelihood is assessed as a probability. Risk impact is estimated in monetary terms. So, and remember, this is why I was telling you that risk assessment needs expert knowledge. And for you, after next year, some of you will do your startup companies and so on. Now, when you start, you'll make very poor estimates, very poor judgment. But as the years go by, and if you are following proper project management procedures and keeping your information, then you'll be able to do better assessment. So risk exposure is an expected cost in a similar manner to cost-benefit analysis. So remember, we did cost-benefit analysis. So this is a cost. Now that cost comes from probability of occurrence and the money. So ranking schemes can be used to assess the impact and the likelihood. So impact scores should take account of the cost of delay. So you need to know if a supplier delays supplying me certain material, what is the cost to me? Then the cost of overruns, cost by using additional or more expensive resources. One of the people you employed in your project team falls sick. Now, you need to ask yourself, okay, do we continue without him? Do we employ somebody temporarily? Now, if we are employing somebody temporarily, remember, you are doing it as a stopgap measure. So whoever you will approach will know that you're desperate and is going to put a higher value. So you need to think about the cost of overruns, and then the costs incurred or implicit in any compromise to the system's quality or functionality. You have 4 programmers, 1 falls sick. So you ask yourself, if I continue with 3, the three. Will I compromise quality? Will I take a longer time? Now, if I bring in somebody else, what is the implication in terms of cost? So these are what we call impact scores. So part of a risk exposure assessment table looks like this. Like, for example, in software, in software projects, you could have changes to the requirements during specifications taking longer than expected, staff sickness affecting critical path activities, staff sickness affecting non-critical path activities, and so on. So as you can see, I'm talking about likelihood, impact, exposure, where I said least likelihood, which is in terms of probability, risk impact, which is in terms of money. So when you are doing a risk assessment or a risk exposure, then first of all, you shall have done the risk identification. Now, these are just parts of risk identification. So you ask yourself, what is the likelihood? What is the impact? You multiply. Likelihood, impact, multiply, and you keep on doing this. Now, once you have done this, then you prioritize them. The higher the exposure, the greater the attention you pay to that particular hazard. So, having done that, we have done risk estimation and evaluation. We have done this. We've done these three. The next we are going to do is risk management. Yes. 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 Most of the time, it has to be a monetary value, or if it's not a monetary value, you must have a unit on it. Because here I've said this. I've said risk likelihood and risk impact. Like here I've said likelihood and impact. Now, as you can see in this table, this is a theoretical table because we've said likelihood is measured as a probability and impact is measured in terms of monetary values. But as you can see in this table, I've not exactly done that. So let us not fix those as the terms. Let us say this, depending on the project you are dealing with, you should decide on the unit that you are going to use. Like likelihood, if it's probability, it has to be between 0 and 1. Impact, you could use a scale where you are going to say, I'll rate it between 1 and 10. But if it's possible, if you could get monetary values, that's going to give you a better value. I don't know whether that is where your question is leading to, or what you're asking. Sorry? Okay. That's my mistake. You see, I've said, first of all, risk assessment has to be done by experts, but different projects can come up with their own standards of doing risk of the units they'll be using to do that risk assessment. Yeah.
Excuse me, I have a question.
Yes.
Uh, we've spoken about risks in terms of hazards that might adversely affect a project, but what
Yes.
about situations where you're a project manager who's managing a software project and see there's an opportunity to to add an incremental change that might improve the product that you are currently working on? Like a risk that's not a hazard, but rather a risk that's an opportunity to, I don't know, add value to the project. How do you capture that? Because I think from PMP, they were talking about risks in terms of hazards and also opportunities.
Sorry about that. It was my network.
Oh, it's okay.
Go on with your question.
I don't know where I lost you.
Okay, start with the question. Just that.
I just wanted to ask, like we've been talking about risks in terms of hazards. So what about risks that are opportunities that you can um, take advantage of? Like, let's say it's a product feature that needs to be added, but it's a risk in terms of it's either an opportunity, but not really a hazard. I don't know if that makes sense.
Okay, you have just seen an opportunity. Oh, okay, you've seen an opportunity. Like you are adding. Okay, let's say you are adding a functionality onto a software product. Is that what you're saying?
Yeah, but as a risk in terms of an opportunity, not a hazard.
Okay, very interesting question. Anyone who can suggest an answer to that?
Yeah, it's odd because when I was reading PMP, that's what they were saying, that a risk can be either a hazard, like you've told us, or an opportunity, but they did not explain it well.
Oh, okay. Uh, first of all, most times, a lot of entrepreneurs have made it in life by exploiting an opportunity. But but you see, the when you want to explain an opportunity, you have to test you have to take risks. Now, I'll give you an example in terms of software. When COVID came in 2019, it came out of the blues. Now, as it came out of the blues, what happened? People said we are not going to work, so you could not attend lectures because of the risk of infection. Now, as a software developer, somebody sees an opportunity uh, to come up with a project to develop an online teaching system. Now, you see, COVID in itself is not a nice thing, but here is a person who has seen an opportunity there. So what does he do? He says, "I'm going to develop an online teaching application." So as he's developing it, how sure is he that that product is going to sell? So he's taking a risk. He has seen an opportunity, but he's taking a risk, and the risk is that the product may pick or the product may not pick. So if it picks, very well for him, he'll make his money. If he doesn't pick, then and how does he know that it's going to that COVID will persist for as long as it has done, as it did? Supposing it goes away after a vaccine is found after 3 months, then his product is not going to be used. But as you can see, as in the case of COVID, what has happened? It has changed the way we do our teaching. So he saw an opportunity, he took a risk, and the gamble has paid off. So just like you see, it's an interesting question. That's why I was asking: is there anybody else who can contribute to that? But that's a very good observation. You know, when you think about risks and opportunities, you need to be a bit careful. So at that time, it's a new product. So you actually don't know the risk. But what we say is that you're just going to take the risk. And in that case, you'll accept to fail. If you fail, too bad. I don't know whether that helps you.
Yeah, actually, I've liked the analogy you've used for COVID-19. You've answered
Okay.
that. Thank you.
Okay. Welcome. Okay, we have said that. So risk management, managing risk involves the using of the use of two strategies. One, reducing the risk exposure by reducing likelihood and impact, and then drawing up contingency plans to deal with the risk should it occur. So we have looked at these two. We have looked at likelihood and impact. So the thing is, once you have this table, you ask yourself, is there anything we can do to reduce it? And that may involve, okay, do we hire more staff? Do we change A from that role to this role, and so on? So all attempts to reduce risk exposure will have a cost. The risk reduction work should be prioritized to obtain the best value. Actually, for risk analysis and risk management, you need to sit down. You need to have a meeting. So factors other than risk exposure that should be taken into account when prioritizing risk management is, first of all, ask yourself, what level of confidence do I have in risk assessment? These people that I'm using, uh, are they competent enough to give me their expert judgment? Then two, compounding risks. Compounding risks means adding the risks together. Then the number of risks, then the cost of action. Now, cost can be compared using the risk reduction leverage, another very hazy concept, where the risk reduction leverage is equals to the RE before and RE after, where RE before is the original risk exposure value, and RE after is the expected value after you take a certain action. Now, as you can see, this is dependent because how do you know this exposure value? If you have done a similar project, then you will do that, you will know. But if you've not done that project, then you're just beating about the bush. So you may be lucky, you may not be lucky. So we normally use the what is called the risk reduction leverage, and this is the formula for risk reduction leverage, where we are looking at the original risk exposure value and then the expected value after action. Now, of course, this is going with this table. You shall have seen this. Then, after you have done this, you shall take, because the exposure will tell you and it will help you to prioritize the risk. Now, after prioritizing the risk, you don't leave it at that. You say, yes, this risk is risk I should take the highest priority. So what can I do to reduce it? Then this is what we are calling the risk reduction leverage. So it is RE before, RE after, then the risk reduction cost. So how do we reduce risks? We have uh, 5 broad categories of risk reduction. One, hazard prevention, likelihood reduction, risk reduction, risk transfer, and then contingency planning. So again, this involves a lot of meetings and brainstormings. How do you reduce the hazard? First of all, you'll have known this is the hazard. How do I reduce it? Now, for example, you say supplier is a hazard. How do you reduce that hazard? Now you may say, let's advertise and let people apply. Then let's have a way of assessing these applicants and then choosing the best. Then the likelihood reduction also would go with that. The risk reduction would be, for example, saying I would rather deal with the programmers I know than programmers that I don't know. I would rather pay the programmers I know more than take a programmer I don't know and pay less. Then risk transfer, where you say this part of a project is not too important. And I mean, yeah, okay. If we use the scheduling, where we have the critical path and the non-critical path, where you say, okay, let me transfer people to this person to the critical path because I don't want anything to happen here. So let me transfer the risk to a non-critical path. Then contingency planning is where you say, you look at, supposing it happens, what am I going to do? So these are all the things that you do to try and reduce risks. Then the last is risk management. Risk management involves these things: risk planning, risk control, risk monitor, risk directing, and the risk. So risk planning, preparing contingency plans. Large projects will use a risk manager to do this. Yeah, it's the people these days who yes, they are project managers, but they are specific to risk management. So you will have a risk manager, then risk control, minimizing the effect caused by the problems occurring, and then risk monitoring, ongoing assessment of the importance and relevance of particular risks. So risk monitoring is, yes, you are aware of the risk, you listed them. Now, as the project progresses, you keep looking at the hazards and how they are changing. And then risk directing and staffing, the day-on-day management of risk, the risk aversion, and problem solving. So these come under risk management. And this brings us to the end of that lecture. Now, of course, like I said, I'm just talking about this, but for the remaining part, we shall keep revisiting some of these things. So any questions? Risk transfer is, you look at two hazards. Just like I was saying, you see, when we are doing the critical path analysis, we know that there is this critical path which nothing should occur to it. Now, let us say that you have one member of staff who is working on a task that is on the critical path. Then you realize that this is not somebody I can depend on. So, but you're not going to remove him from the project team. What you are going to do is that you are going to replace him with somebody that is more dependable. So what you are doing is you're transferring the risk from the critical part to another part that is non-critical. So that is in terms of stuff, in terms of staffing, because you are removing this person from a critical path, because since he's not dependable, if something happens to him and you put him on the critical path, then obviously, because he's not dependable, he may miss coming to work for a week. Then he's going to affect the project. So what do? Take him to another uh, path that is not the critical path. So you see, you've transferred that risk from the critical path to another path because he is the hazard. So you don't want him to affect any task on the critical path, because if he does something, then the project will delay. But if you take him to a path that has a slack, yes, he can miss for that 1 week, but the project will still be on schedule. So in other words, you have transferred the risk from the critical path to another path. That is how I can explain it. Are you comfortable with that? Okay. So next, we look at project quality. I hope we'll finish it in time, but it doesn't really deal with much. Now, again, I'm being specific to software project quality. That's why I've just put it for software project quality. Now, quality is a very sensitive issue. Sensitive in that it cannot be a face. Quality is in the whole project. You cannot build a product and say that I am now going to build quality. You build quality into a product. You don't say that quality is a face. And now quality becomes difficult to handle, especially in software projects, because of the intangibility of the projects. Now, for a long time, people just build products, and then they didn't realize the importance of quality. Now, there's a person, he was actually an American, who first of all highlighted the importance of quality. I've just forgotten his name. He was a professor in America, and he introduced the concept of what is called total quality management. Now, in very simple terms, he was preaching that message to the Americans in his university, where he's the first person to introduce the term total quality management. People didn't take him very seriously, and he somehow migrated to Japan. And then the Japanese embraced his theories on total quality management. And then within a very short time, people started noticing that the Japanese were producing products which were high quality. In other words, they were introducing cheap products in the market, and yet people liked those products. And you see, the Japanese were selling those products to the Americans. Now the Americans started asking themselves, what is it about this Japanese? What is it about their products? Why are people buying these products and not buying our own products? Yet we are superior to them technologically. Then when they studied, they came across the term total quality management. Now, in total quality management, by the way, it's a whole course. You can get an MSc in total quality management. But the basic thing it says is that quality is built into a product. Quality can never be a face in a product. So that is what we want to talk about. So at the end of this lecture, the learner should be able to explain the importance of project quality, define software quality, evaluate the various quality standards, describe capability maturity level, describe the various quality planning techniques. So quality in introduction, quality is generally agreed to be a good thing. You find people always talk about, I bought a quality item. This car is of high quality. This shoes is of high quality. And so on. Now, quality doesn't mean the amount of money you spend. You can spend very little money and buy a high quality thing. And that's why quality is very difficult to define. So often the use of procedures that will help ensure a product system's quality will not be lacking. Quality systems must be defined. Metrics should be used to check quality systems. Now, why am I talking about quality? I'm talking about quality because you are producing a product. You do not want to just deliver the product to a customer. You want the customer to be satisfied. And how is the customer satisfied? The customer is satisfied if there are certain things in the product, if all the things he wanted in the product are there. Now, for software, quality becomes difficult because, one, the increasing criticality of software. Now, we find software in everything, from washing machines, from cars, and so on. So it's very difficult to find a product that does not have software. So software is critical in all systems. Therefore, software quality becomes very important. Then the problem with software is that it's intangible. And the other thing is that errors accumulate during development. If you don't deal with an error initially, like with software, we start from requirements. Now, if you get your concept of requirements wrong, then you shall find that that error is going to go throughout the project. You misunderstood a customer's requirement. When you are designing based on what you misunderstood. When you are coding according to the design specification. Now you can see that error is compounding, is becoming larger and larger. So for software, quality now becomes of importance. And like I've said, we are doing project management. So in project management, the thing is that you're going to produce a product. You're not just going to produce any product. You want to produce a quality product. So we need to define what software quality is. So we should have, software quality should have 3 specifications. Now you must have functional specifications. What does the system do? Quality specification, how the system operates. Resources specification, concerned with the resources the system requires. Now, of course, by now you should know this. Functional specification is are you meeting what the customer wants? Quality specification. Are you using the right standards? And then resources specification. You know, you could design a system for a customer, but that system, yes, it does what he wants, but it's using a lot of resources. It's using too much processing power, it's using too much memory. Yes, it's doing what the customer wants, but at the expense of the resources. Now you delivered something to a customer at a much higher cost than you'd normally have done if you followed the right specifications. Now, why quality becomes abstract is because of the measures that you need. So quality standards are set by standard setting bodies. Now, today I'm just mentioning them. I really do not want, I want you to understand the philosophy, not to understand, to know, I mean, to cram what they are, to just know that if you are talking about quality, then there must be certain standards. Like University of Nairobi, you will end up with a degree, BSc Computer Science. Now, why don't they just give you a BSc Computer Science? Why do they say you have a first class, you have an upper second, a lower second, and a pass, or you don't have any certificate? Why? And why is it that when you go to an employer, they look at that classification, which is not a very good way of judging people, but that is where they start off from. So we have those classifications to indicate the quality of a product. Like in this case, the product is a BSc degree. So in terms of software, we have certain standards. Now I'm just talking about international standards. We have the ISO 9126, which was published in 1991. Now, ISO 9126 provides a definition of software quality. Now, you can go to and Google this ISO 9126. It's an international standards organization. Now, the version, because we have very many ISO standards, the one that specifies software quality now, ISO 9126 defines 6 software quality characteristics. So, in other words, it defines what is software quality. Now, it has functionality, which covers the functions that a software product provides to satisfy a user's needs. I mean, you must meet that if you are a software developer. Reliability relates to the capability of the software to maintain its level of performance. Usability relates to the effort needed to use the software. Efficiency relates to the physical resources used when the software is executed. Maintainability relates to the effort needed to make changes to the software. And portability relates to the ability of the software to be transferred to a different environment. So ISO 9126 says quality software must have these characteristics. Now, here I am talking about it at a very general level. If you download that standard, it's going to talk at it. It's going to talk about it at a very detailed specification. Then, how is software quality measured? Again, we measure software quality in terms of reliability, which could measure availability, mean time between failures, failure at the time of operation, number of faults to be dealt with. Maintainability is related to flexibility, and then extendability, which is the ease with which new features can be to the software. Now, for further details, you can download this, or I can look for it and give it to you. I think I have it somewhere. So we have said that. We've said for you, I've said quality is abstract, and for you to talk about quality, you must have some metrics, some measures for that quality. Now, having seen that, we have what is called product versus process quality management. Now, you need to differentiate between these. What is the difference? Why is it important? Well, often one or the other is looked at. Both should always be considered. Now, there is, let me see if somebody is. Because it's 10:37, probably that's where we shall stop. So let me just wind up here. There is the product that we're creating, and there's the process that you use to come up with the product. Now, I'll use a very crude example. You did a project in second year. You're going to do a project in fourth year. More often than not, we ask you to propose a project, and you propose. Now, what happens is that during the proposal, you say, this is what I want to do. I want to build a medical patient management system. So we say, yeah, that's okay. Go ahead and build the product. So during the proposal, you propose to do something, we've okayed it. Then you start the project. Now, at the end of the project, you present something that is working. So you present a product that is actually running. Then somebody asks you about a functionality, and it's not there. Then somebody asks you, did you do systems analysis? You start scratching your head. What is systems analysis? Which design methodology did you use? I'm not too sure. Or I use software development. I use the waterfall model. Then you are told the waterfall model is not a formal methodology. It does not matter which system you are developing. Whether you're developing a safety critical system, an information system, a knowledge-based system, they'll go through the stages in the waterfall model. You'll have to gather requirements. You'll have to do a systems analysis. You have to design. You'll have to code. You'll have to test. You'll have to document. All products, regardless of what they are, go through those stages. So you're taking a formal methodology. Now, why am I saying this? I'm saying this because you delivered a product, but you didn't use the correct, or you didn't use a formal methodology. And this is what we are saying: product versus process quality management. So what I'm trying to emphasize here is you need to differentiate the two things. You need to differentiate between a product and the process that you use to develop the product. So you must have quality in all of them. Your product of high quality as defined by and as measured by these things. And you must use a quality process. So in project management, you must differentiate between product and process quality. They are not the same. So for you to end up with what is called a quality product, the product must be of high quality and the process should be of high quality. So we shall stop there. And I'll leave you these questions to ponder at. What is the difference between these two? And why is it important? The difference. So now that we are doing project management, at the end of this course, what I expect you to do is you just produce you must know the metrics which we use to measure your product, and you must know that to come up with a good product, you must also have a quality process. So you differentiate the two. So for today, I want us to stop there and pick up from there. So like I said, I will, by the end of today or latest tomorrow, I'll give you the first assignment. And please sign the register. For today, I forgot to put it online, but I'm sure you can access it. Please sign it. So we'll stop there.